Chapter 5, Methods, Part 3. So methods without return values, methods are not required to return a value, and sometimes we just want them to do something. We don't necessarily want them to calculate something. So the return type of void is used when a method returns nothing, and we don't have a return statement. We could have a return without a value associated with it, but we don't have to. And the method can generate output. So for example, if we want to say public static void box string, and we're sending it some variable for string, we figured how long that string is. We have a for loop that's going to print the number of dashes to provide the top. Then we return to the beginning of the next line. We print an exclamation point, the string that was sent as a parameter, and then an exclamation point, and then another for loop where we print the dashes on the bottom, and then we return to the beginning of the next line, and the method's done. So it does not have a return type. However, it did have a parameter. We passed that string that we wanted to appear inside the box. We can use return without a value. For example, if we call the same method we saw on this previous slide, but let's assume that this string is the empty string, so there's no no characters associated with it, we can check for that first. If n, that's the string length, if n equals 0, return. That means don't even try to print the box string because it's not going to make any sense. There's no string length here. So we can return without returning a value. So think about reusable method. A good way to approach this is to find repetitive code in your programs. You might have different values but the same logic. Like let's say you're coding a game and each player is taking a turn. The logic associated with the turn is the same. It's just that each player is taking their own turn. That might be a good example of reusing code. Here, in this example, we're doing the same code for hours or minutes. We want to enter an hour between 1 and 12 or minutes between 0 and 59. It's the same basic idea, it's just different values. So for hours it would be 1 to 12, and for minutes it would be 0 to 59. We can write a parameterized method that in which we provide the range that we want that value to be in. So public static int read value between int low, int high. So we're providing the low value, we're providing the high value. And then inside the method int input do system.print enter a value between low and high. Scanner in equals new scanner system.in. Input equals in.nextInt while input is less than low or input is greater than high. So less than low means it's too low, greater than high means it's too high. So as long as either one of those is true, we keep looping and prompt the user to enter again. Once that expression is false, that means the user has entered a value in the range that I'm looking for, or that you're looking for, the programmer's looking for, and then we return input. So we return whatever the user entered as soon as it is in the given range. And in this example, high would be 0 to 59. And, oh, excuse me. Those arrows are pointing to the wrong thing. It would be 1 to 12 for low or 0 to 59 for high, whether you are reading hours or minutes. Stepwise refinement. To solve a difficult task, it's easier to break it down into simpler tasks, more simple and simple tasks, and then keep breaking it down until you have very simple tasks to solve. Think of getting coffee. Can you ask someone to get coffee for you? If yes, ask for coffee. If no, make your own coffee. Then if you're making your own coffee, you can say, okay, do you have instant coffee or do you have brew coffee? And you can break those steps down even more. If you have instant coffee, make instant coffee, which involves boiling water. Do you have a microwave? Yes, fill the cup with water. Put the cup in the microwave. Heat it for 3 minutes. No, fill a kettle with water. Bring to a boil. Mix the water and the instant coffee. So you see, we're breaking it down into smaller and smaller steps, more discrete steps. And this is a great problem-solving technique when you look at a big problem and then drill down and get smaller and smaller until you can actually code the solution. And here is with brew coffee, and you see there's lots of steps involved there.